Today we're going to start chapter 4, which is all about inequalities. So in lesson 4.1, we're just going to introduce inequalities. So the first thing to talk about is the law of trichotomy or trichotomy. Actually, not sure which way to say it. I want to say it's trichotomy. So law of trichotomy basically says that only one of these statements down here in blue can be true at a time. It really makes logical sense, right? If we've got A equals B, A less than B, and A greater than B, it makes sense to say that only one of those can be true, right? We can't have A equals B and A greater than B true at the same time. It doesn't work. So basically what this law states is that you can only have one inequality symbol true at a time. Okay? But this law of trichotomy might come up later. It could be something you see on a test, could be on a quiz, could be a pop question or like a bonus question. So if you can remember what this law is, law of trichotomy, and what it says, might benefit you later. All right, let's talk about the inequality symbols. So we've got an equal to sign, a not equal to sign, less than, greater than, less than or equal to, right? That's the less than sign with a bar underneath it. So less than or equal to, and then greater than or equal to. So all of these symbols are what we're going to see in this chapter, and specifically this lesson. So when we're graphing inequalities, which is what we're going to be doing in this lesson, we're going to be using a number line. So that's why I gave each of you a piece of paper with a bunch of number lines on it in class yesterday. So you're going to want to be sure and pull that out, because we're going to use some of those number lines for our notes, and then you can use the rest of the number lines for your homework. So number lines is how we're going to graph inequalities for now. There's two things you have to keep in mind when we're graphing inequalities, okay? You will either use a closed dot or an open dot. A closed dot is when the number that you start on is part of the solution. Basically, it can be equal to. So when you have a less than or equal to sign or a greater than or equal to sign, those are keys for closed dot. Okay? Open dot is when the number that you start with is not part of the solution. So it is not equal to. So you're going to be looking for just less than signs or just greater than signs. Okay, no equal to bar. So equal to bar means closed dot. No equal to bar means open dot. If you can remember those two things, you will be just fine on this lesson. So let's do some examples. We want to graph the inequality x greater than or equal to 2. So x is every solution that we could possibly have to this problem, and that solution must be greater than or equal to 2. So what you're going to do is go on your number line, you're going to start at the number 2. So here's the number 2, and then the question becomes, do I use an open dot or a closed dot? Well, I have an equal to bar. Remember, equal to bar means closed dot. It means 2 is a solution. Let's see, sometimes my pen is a little finicky. All right, so we got a closed dot at 2. And guys, please make your dot big enough or use a colored pen or something, because you need this to stand out. Now on a test, you won't be able to use pen. So just find a way to make this stand out, okay? I need to be able to look at your graph your number lines and know where your dot is and which way your line goes. So just be prepared to make that stand out. All right, now we've got our starting point. Our starting point is at 2. Our solutions are everything greater than or equal to 2. We've already taken care of the equal to 2. That's the closed dot. So our solution is everything greater than that. So you're going to shade an arrow towards everything greater than 2. And you can put arrow at the end because it doesn't stop just because our number line stops. It is every number that is greater than or equal to 2 is a solution to this inequality. Okay, let's look at the next one. We have x less than 4. All right, so our starting point is a 4. So we go find 4 on our number line. But then we have to ask, do we use an open dot or a closed dot? Well, if it just says less than 4, there's no equal to bar. There's no equal to bar. That means that 4 is not a part of the solution. You only want the numbers less than 4. So you're going to use an open dot. And then our arrow needs to include everything less than 4. Everything less than 4. So you're going to go to the left towards everything less than 4. And you're going to keep it going all the way to the end and give it some arrows. Because it doesn't stop. It keeps going. Every number less than 4 is a solution. All right, so the next one says x less than or equal to -3. Okay, our starting point is a -3. We have an equal to bar, less than or equal to, which means that we use a closed dot. And now we want every number less than -3. Every number less than -3. So you need to go to the left, the less than side, and give it some arrows. Okay, the next one, this one's where they're trying to get you. They said x cannot equal 1. Remember, this symbol means not equal to. X is not equal to 1, but it can be anything else except 1. It can be anything on the entire number line and beyond, but just not 1. So if we go to 1 on the number line, we know x cannot be 1. So it's going to be an open dot because 1 is not part of the solution. But every other number is part of the solution. Every other number. That means you can go in the left direction and all of these numbers are solutions because they're not 1. Or you can go in the right direction because all of these numbers are not 1. Okay, so basically we have an arrow extending in both directions, but you just have to put that open dot at 1 because 1 is not a solution. All right, the last one says x greater than 2. So our starting point is at 2. It just says greater than. There's no equal to bar. So that means it's an open dot. 2 is not part of the solution. We just want the numbers that are greater than 2. Well, greater than 2 is towards the right. All of these numbers and beyond are greater than 2. Okay, so we've got the graphing side of it. Now, let's talk about determining if something is a solution. So, our instructions say, determine if each value is a solution to the inequality 2x plus 3 is greater than or equal to 7. So we're given an equality, and in letter A, we're told x equals -2. So all you need to do is plug in the x equals -2. Oops, too far. In for the x and determine if the inequality comes out true. Okay, it's just like checking a solution for an equation. You can treat your inequality sign very similar to an equal sign. So we're just going to plug it in and see if it comes out to be true. So then we're going to take 2 times a -2, because that's what x equals, plus 3, and decide, is that greater than or equal to 7? We got to find out. What is 2 times a -2? It's a -4 plus 3. Is that greater than or equal to 7? Well, what's a -4 plus 3? That is a -1. Is -1 greater than or equal to 7? No, it's not. -1 is smaller. It's smaller than 7. So the answer is not a solution. X equals -2 is not a solution. Let's try another one. We've got the same inequality, 2x plus 3 greater than or equal to 7, but this time we're going to let x equal 0. So we say 2 times 0 plus 3, is that greater than or equal to 7? What's 2 times 0? It is 0 plus 3. Is 3 greater than or equal to 7? No, it's not. 3 is less than. So this also is not a solution. Not a solution. Okay, the last one says x equals 2. So we're going to plug it in. Now I've got a 2 times a 2 plus 3. Is that greater than or equal to 7? What is 2 times 2? That's a 4. Is 4 plus 3 greater than or equal to 7? Well, you get 7 greater than or equal to 7. Is that true? Yes, it is, because 7 is equal to 7. And you have an equal to bar. So they are allowed to be equal. So this one is yes. It is a solution. That one is a solution. Okay, now let's use a different inequality and let's try a different number. So let's see, does x equal 2? Is that a solution to 3x plus 6 greater than 12? So we're going to write our inequality and we're going to plug in a 2 for x. And we're going to find out, does that come out to be greater than 12? What's 3 times 2? That's a 6 plus 6 greater than 12? Well, what's 6 plus 6? It's 12. Now think about this for a second. Is 12 greater than 12? No, it's not. They're equal to each other, but it's not greater than. And there is no equal to bar. We're not allowed to be equal. We only want to be greater. So in this case, this is not a solution, because 12 is not greater than 12. Okay, so we've got the graphing of inequalities. We've got the checking to see if a number is a solution. The last part of this lesson is going to be writing inequalities based on a word problem. Okay, so if you look at page 129, at the very top of page 129, I'll write this on here. This chart is on that page. Okay, now I suggest you write it down, because if you write it down, you're way more likely to memorize it, and it's not going to be given to you on a quiz or a test. So you're going to have to know it. But for now, the chart can be really helpful. Okay, so you've got some key words here. If we're talking about less than, some key words for less than. Actually, let me ask you this. What is the symbol for less than? Less than goes this way, right? So key words for less than are fewer than, under, and below. Okay, so then we've got key words for less than or equal to, which what's the symbol for less than or equal to? It's a less than bar with a line underneath it. Okay, keywords are at most and no more than. At most and no more than. So then we've got greater than and greater than or equal to. So greater than is going to go the other way. And greater than or equal to is going to be a greater than sign with a bar underneath it. All right, so keywords for greater than are more than, over, and above. And keywords for greater than or equal to are going to be at least and no less than. Okay, these are going to be really helpful. So I'm going to suggest that you look back at these when you're doing your homework. So let's put it into practice with some examples. We're going to write an inequality. We're not solving it. We are only writing the inequality, okay? It says the sum of a number and 3 is at least 7. Let's pick out our keywords. What does sum mean? Sum means to add. A number. Do we know what a number is? No, that's going to be your variable. And 3 is just a 3, right? But you're doing the sum of a number and 3, so you know that you're going to add them together. Is would technically be like an equal sign, right? But you can't stop at is. It's at least. So what is at least a keyword for? This is where your chart's going to come in handy. At least is greater than or equal to. It's at least 7. Greater than or equal to 7. So now we have to go write our inequality. Okay? We've got the sum of a number and 3. That is x plus 3 is at least, that's greater than or equal to 7, right? The sum of a number and 3 is at least 7. That means it can be 7 or it could be more than 7. And so this is all they're looking for, is can you write these words into an inequality? All right, I got 2 more examples, or 3 more examples for you. The next one says, the number of cars, and it's technically at a dealership, the number of cars at a dealership is fewer than 75. All right, number of cars. Do we know what that number is? No, that's X. Is would be like an equal sign, but you can't stop there because then it says fewer than. What is fewer than a keyword for? Less than, and then you've got the number 75. So the number of cars at a dealership is fewer than 75. And that's it. That's all they're looking for. Okay, the next one says 2 less than 3 times a number is no more than 13. All right, let's take our time. 2 less than. that means you're going to be subtracting 2 at the end of something. You're subtracting 2 from something, but it says 2 less than. So you're subtracting 2 3 times a number. Do we know what the number is? No. So it's 3 times our variable. So what you're doing is you're doing your 3 times your variable minus 2 because it's 2 less than. Then we've got no more than is no more than, which are keywords for what? No more than are keywords for less than or equal to. And then you've got 13. Okay, so 3x minus 2 is no more than 13. Okay, so again, please use that chart on page 129 to help you until you become familiar with it. Be sure you're able to pick out no more than and what that means. Okay, the chart's really going to come in handy. All right, one more example. Oh, nope, that was it. I just had a blank page on here. All right, so 3 things you'll see in this lesson. One is graphing inequalities on a number line. I will be looking for your number lines when I check your work. The second one is checking to see if a number is a solution. You're going to treat it very similarly to an equal sign. You're just plugging it in. And then the last thing is turning your word phrases into inequalities. All right, I will see you guys tomorrow.